All right, so you have this paper out. I'm just going to start solving these. Shh. All right. So our first goal should always be what when we're solving radical equations?
Alone.
Get what alone? Get the radical by itself. That should be your first step. Get the radical by itself. So, how do I get this radical by itself?
Bring it to the other.
So,
Divide by 2.
right. What is attached to the radical right now? 2. How do I get something unattached?
You unattach?
How? You divide.
Yeah.
Divide by 2. What happens on that left-hand side?
7.
Left?
Oh, no more 2s though.
Ah, the 2's cancel, and I'm just left with radical x plus 1 equals 7. Now, does anyone know how we can get rid of that radical? It is a square root.
Square root is 7.
So, you
Add the 7.
put the
Subtract the 7.
I do what?
square.
You square both sides. Remember, guys, what's the opposite operation of square root? Square. Whenever you're solving an equation, you always do the opposite operation. Well, opposite of square root is square. So, we're going to square both sides. What happens on that left-hand side now?
X plus 1.
Right. The square and the square root cancel each other out, and all you're left with is x plus 1. And what's 7 squared?
49.
49. Then what do you do?
Then you bring the 1 on the other side.
Right. You subtract 1 over, and you get.
X equals 48.
That was pretty easy.
Now, what did I say about the solutions?
It was 2 or 1.
Right. We have to figure out if this is extraneous or not. Because sometimes, I know there's only one solution here, but sometimes you'll have no solutions. You have to check whether or not this is a real solution. So we go to our calculator, and we just plug the 48 back into the original equation. So, 2 square root 48 plus 1. And it equals 14. Is that what we wanted it to equal?
Yes.
Yes. So this has been checked.
Can I borrow a highlight?
Now, let me show you a little trick that I want you to do before you do any solving radical equations. Before you even start solving, this is what I want you to do. I want you to go into your y equals and put each side of the equation into the y equal. So this is 2 square root x plus 1 and then 14. Shh. And then you graph it. And if you can't see the 2 lines, it means that you need to change your window. Just so you can see more. How many times do these lines touch each other? 1 time. So how many solutions should we have ended up with? 1 solution. So that's how you can check to see how many solutions you should end up with. If I had done that beforehand, I had figured out, okay, there's 1 real solution, and then I solved the problem and I ended up with 1 solution, do I need to plug that back in to check it?
You probably
No.
should.
You don't need to.
There's not 2 lines.
Right, you need to change your window.
I did.
Make it bigger.
I did.
So this is how I changed my window.
What is your window?
I changed my window to make the X max bigger and the Y max bigger. Or you could just do zoom out, or you could just change them all to 100.
There's still not 2 lines.
You put both the maxes at 100? All right, next problem. What should I do first?
Oh my god, this is too much.
First, before I solve, what do you think I should do? What should I do?
What you want?
What did I just say to do first?
You divide. Find the if there's how many solutions.
Oh, put in the calculator to figure out how many solutions you should end up with. So, on one side I have 6 plus, now this is cube root, so I have to press math, 4, and then yes, it's y, but remember, whenever we see an equation with a variable and we're trying to put it in the calculator, we just substitute x, minus 4, then in our y2 we put 9. So this one I may have to zoom in. I'm really far away here.
Oh shit. Shit. I have to go back. Oh my god, what is going on? Hello? Oh my god.
So, how many times does that line touch the other line?
15.
How many times? Once. We're about to get a seating change.
Okay.
All right, so now we can solve, and I know I should end up with one clear solution. What do I do first? Whoa, now. What operation is happening between the 6 and the cube root? What operation is happening between, they're being added, are they being multiplied? Only when they're being multiplied do you divide, because dividing is opposite operation of multiplying. But they're being added together. So what's opposite of that plus 6? Subtract 6. What's 9 minus 6?
3.
What do I do now to get that cube root off?
Divide by 3.
What's opposite of cube root?
Square.
Cube.
Oh my god, what?
Raise each one to the power of 3. So then we have y minus 4, because the cube and the cube root cancel, equals, what's 3 cubed?
9 times 7. Yeah.
Then, what do we do? You add 4, good. So y is equal to?
31.
How many solutions did I end up with? 1. Is that how many I should have ended up with? Yes. So I'm good.
Oh my god, what is that?
All right, next. Now before, okay, before I show you number 3,
What the hell is this?
do you guys know of another way to write this? Or we'll make it even simpler. Do you know another way to write that? No. Because the square root of x is not equal to x squared. Right? The square root of 4 is not equal to 4 squared, is it? No. You may never, well, you should have learned this, I think. I'll just tell you. The square root of x, another way to write this is actually x raised to the power of a half. No?
No.
It's not common to see it this way.
So basically, you can do like a power to a number smaller than 1.
It has to be a half though, because square root is always raised to the power of a half. Cube root is always x raised to the power of, what do you think? 1/3.
But
What do you think this is going to be?
1/4.
Do you see?
So the 5 root would be x to the power of 1/5.
Yes. Okay, very good. So over here, yes, this is written as 3x minus 1 raised to the power of a fifth. So over here, I'm going to write, what is it, 3x minus 1?
To the power of 1/5 equals 2.
It's the same thing as writing, now don't write this, same thing as writing this. What would we do to get rid of this?
Put it
And do what to it? Raise it to the power of 5. Raise it to the power of 5.
So you switch it now?
Now, I haven't finished showing you the pattern because there's going to be more problems. What would I do if it had been this?
Would you just divide it by 2? Would you just do the opposite? Would you just do the division?
So this is the same thing as writing what?
Wait, what is it saying?
So what did I do to the 1/5 to get this number? What did I actually do?
Flipping.
Oh! I found the reciprocal of it, right? The reciprocal of 1/5 is 5. So what's the reciprocal of 2/3?
3 divided by
3/2. So you raise it to the power of 3/2 to get rid of it. You raise it to the reciprocal. So here, yes, I could just say because I did that pattern, oh, you know it's 5, but really every single time you have a fraction, you just raise it to the reciprocal power to get rid of it. Okay?
same.
So here, these 1/5 and 5/1 cancel each other out. And that makes sense, right? Because what is 1/5 times 5/1? What is that? 5/5.
No idea.
5. What is 5/5? 1. So it's raised to the power of 1. It's itself. So these cancel. And what is 2 raised to the 5th power? No. 2 raised to the 5th power is the same thing as writing 2 times 2 times 2 times 2 times 2. Right? 2 to the 5th power is the same thing as that. Then what do? I add 1 over, and I get 3x is equal to 33.
Then you get 11.
What did I forget to make you guys do first? Yes, I was so excited about the raised to a fraction.
It's fine, you don't have to.
Did anyone check it first? How many solutions should you have ended up with?
1.
You did check it?
Sure.
1 solution? All right, 1 solution. Okay, I was just so excited about those fractions. So, what should you do very, very first? Check the solutions. So, y equals, I'm going to put square root of x plus 18. And on the other side, I'm going to put x minus 2. And I'm going to graph it. How many solutions should I end up with? 1. 1 solution. All right. What do I do now to solve this radical equation? Yeah, so I have my radical all by itself. I don't need to get it by itself. It already is. And to get rid of that radical, I square both sides. And here, the square and the square root cancel, and I'm left with x plus 18. What happens on my right side?
X squared minus 4.
Oh, that's illegal math.
Don't know.
What?
All right. What does the square mean? What does the square mean? If I square x, what does that mean? What? You're multiplying x times itself, right? So if I'm squaring x minus 2, what is happening?
Oh, so it's gonna be x minus 2 with x minus 2.
Yes. Do you think that these two are going to multiply to just give me x squared minus or plus 4? What do I have to do to multiply these?
Box.
The box method you could do, or what else could you do?
Foil.
Ah, distribute, the distribution method. What is x times x?
Squared.
What is x times 2? Negative 2, sorry.
Negative 2x.
What is negative 2 times
Negative
x?
2x.
And what is negative 2 times negative 2?
Negative 4.
Plus 4.
What? Oh.
So I combine my like terms, and I get x squared minus 4x plus 4.
Okay, so this is gonna have 2.
Now, what do I have to do? What type of equation is this? It's a quadratic. How do I solve quadratics?
X.
Move everything to one side and factor. Good. So I am going to subtract x over and subtract 18 over.
What is 4 minus 18? Negative 4.
And I get,
X squared minus 5x minus 14.
good. And then again, how do I solve this quadratic? You do your x method. You factor it.
This is terrible.
And up top goes negative 14, and the bottom goes 5. What multiplies to get negative 14 but adds to get negative 5? Yes. Negative 7 times 2. Negative 7 times 2 gives me negative 14, and negative 7 plus 2 gives me negative 5. Those are my two factors. So my factors are x minus 7 and x plus 2. Are these my solutions?
No.
No. What do I do to get my solutions?
X plus x equals 7, x equals minus 2.
Good. So all you do is set them equal to 0, x equals positive 7, and x equals negative 2. But how many solutions did we say we needed? One solution. I want everyone right now to figure out which one of these is the extraneous and box it in. I'm going to come around and check. All right. Number 5 is actually much easier than you think. What should we do first?
Square.
First, graph to see how many solutions there are. X plus 2 and 2x plus 5 and graph it. Uh-oh. So, what's wrong here?
No solution.
Do they ever touch? No. So would I be kind of wasting my time solving this?
Yeah.
Oh yeah, I would.
So that's why you do.
Ah.
Yeah.
But really quickly, how would I solve this?
Square.
You just square both sides because they are both square rooted. So this would end up being y plus 2 equals 2y plus 5, and then I can solve, blah, blah, blah. Realize it's no solution and realize I wasted my time. All right, number 6. What should I do first? Calculator. So I have square root of x plus 23. And then I also have 2 square root of x plus 11. 11. How many solutions should I end up with? One solution. Now I can solve. Our very first step in solving radical equations is always to get the radical by itself, right? Is it possible here to get both of our radicals all by themselves? No matter what I do, is one of the radicals going to have something on it? So say I divided by 2. These two cancel, but what am I left with over here? 1/2. So is something still on that side? So is it possible to get the radical by itself? No. This is the only time when you have two radicals, one on each side, this is the only time that you can jump right into squaring both sides. So here, the squares cancel out. Here, I am squaring how many things on that left hand or right hand side? How many things do I need to concentrate on squaring?
3.
So I need to square the 2, and I also need to square the square root. So the square roots cancel, but then what is 2 squared? That is the only tricky part. You have to square both of those terms. And then in parentheses, m plus 11. This is harder than any problem you'll see on a test, okay? I won't ask you to do this. I'm just going to show you how to do it. Then we have to distribute the 4. Is this a linear equation or a quadratic equation? Linear. So how do I solve a linear?
Move things to one side.
Variables to one side, constants to the other. So I'm going to subtract m over, and I'm going to subtract 44 over. And I'm left with, oh, not 4. 4 minus 1 is 3m. And 23 minus 44? Perfect. And then what do I do? Bye. And I get
N equals -7.
Now I know this is strange, it's negative. Do I need to go in my calculator to check it? Do I? Or what did I do first?
You already did.
I already did it. I already checked. Was there one solution? Yes, there was. I found it. It's -7.
Is it still valid because negative?
Yeah, I mean, I can even look. Where do they intersect? What x value does it look like? It does look like -7.
Which cannot be.
Hint, hint, hint on multiple choice solving radical problems. On multiple choice, do you have to show your work? No. What do? You do what? Put in the calculator. All right. Any questions?